In this video, you are going to learn about the confidence interval for one population variance. So the symbol for the population variance is sigma square. For the confidence interval for population variance, we can use the chi-square distribution to construct the confidence interval for the variance. Consider that the chi-square distribution is given as n minus 1, the sample variance divided by the population variance. So this is the symbol for the chi-square. And now, if we let 1 minus alpha be the area of below curve, so here is our 1 minus alpha. So the interval would be between the chi-square 1 minus alpha over 2 n minus 1 and chi-square alpha over 2 n minus 1. Okay, so the probability of the chi-square distribution would be between these two intervals, which is equals to 1 minus alpha. Now we want to construct the confidence interval for one population variance. So let's say here we defined our lower limit as A. Okay, here is our A, and the upper limit is our B. So A is equals to chi-square 1 minus alpha over 2, and degree of freedom is n minus 1. And for upper limit is chi-square alpha over 2 n minus 1. So if I rewrite this back, it will be A less than, so given the chi-square formula is n minus 1 s square over sigma square. And also I replace this chi-square with this formula, less than equals to B equals to 1 minus alpha. Okay, now we want to rearrange this where I will get A, okay, and I will bring this numerator to both sides. So I will divide it as n minus 1 s square less than equals to 1 over sigma square less than B over n minus 1 s square. So now our equation is like this, and we just want to find the probability for the population variance. So how can we just let this as sigma square? So what I will do is I will take the reciprocals, okay, where it will be 1 over sigma square. So here would be our sigma square, okay, and then 1 over A over n minus 1 s square, it will be n minus 1 s square over A. And this one is also becomes n minus 1 s square over B. So taking the reciprocals will make the symbol here could be reversed. So now it becomes greater than and greater than. So if I rearrange this, so I will get here, this is our lower limit s square over B less than equals to sigma square less than equals to n minus 1 s square over A. So if I putting back, okay, this upper limit A and B into this equation, and we know that the confidence interval for one population variance, okay, will be n minus 1 s square over, so B is chi-square alpha over 2 n minus 1 and n minus 1 s square chi-square 1 minus alpha over 2 n minus 1 equals to 1 minus alpha. Okay, so this will be our confidence interval for one population variance. Okay, you can try watch the video, okay, to understand more on the confidence interval for variance and standard deviation. Now let's try examples so that you can understand more on this confidence interval for population variance. So a precision instrument is guaranteed to read accurately to within 2 units. Okay, so a sample of 4 instrument readings on the same object yield the measurements 353, 351, 351 and 355. Okay, now we need to find a 90% confidence interval for the population variance. So for the population variance, okay, so the formula would be n minus 1 s square over chi square alpha over 2n minus 1 n minus 1 s square chi square 1 minus alpha over 2n minus 1. So meaning that from here we need to know the number of sample n and also the sample variance s square. Okay, so if you refer to here, okay, we have the number of sample which is 4. So our n is equals to 4. But okay, we don't have the information doesn't state the sample variance, but they give you okay the readings of the instrument. Given that the reading of the instrument is 353, 351, 351 and 355. So meaning that from this value we can get the variance from these four measurements. Okay, so you can use your calculator to obtain the variance. Okay, so the variance sample, so if you use calculator, you have to use the sample that refers to n minus 1. Okay, so from the calculator, the sample size will be 3.6668. Now we have these two values. The next one, we need to know the values for the chi-square. So given that this is our confidence interval, which is 90%. So 90% is referring to 1 minus alpha, given that it is 0.9. Okay, so alpha would be equals to 1 minus 0.9, which is 0.1. So alpha over 2 would be equals to 0.05. Now, the next step is you need to know what is the chi-square 0.05. So, n minus 1 is 4 minus 1, which is 3. Okay, and then you also need to know what is the value for chi-square 1 minus alpha over 2 for this one. Okay, so 1 minus alpha over 2 would be 1 minus 0.05, which is 0.95. And minus 1 would be 3. Okay, so you have to refer to the table of chi-square distribution. Okay, by referring to the Blumen statistical table, go to table G. So table G refers to the chi-square distribution. Okay, now here we have this column okay, of alpha. So alpha refers to your chi-square alpha. So from your problem, okay, we need to find two values of alpha. The first one is for 0.05. So for 0.05 is this column. Okay, and the degree of freedom refers to your n minus 1. So our case, n minus 1 is equals to 3. Okay, so this is where you should take the value. Given 0.05, 3 would be 7.815. Okay, so this is the value for chi-square 0.053, which is 7.815. The second chi-square that you need to find is 0.95 and n minus 1, 3. So the value for that would be 0.352. Okay, now that is the way how we use this chi-square distribution. So now given chi-square 0.053 is equals to 7.815, and for 0.953 it is 0.352. So now we have all this information So you can just put the value into this formula. So n minus 1 would be 3 times with s squared, 3.668, divided by chi square alpha over 2 is this one. Okay, 7.815. And for this one is 3 times with 3.6668 divided by chi square 1 minus alpha is 0.352. Okay, now you can solve this. We'll get the interval is between 31.25. Okay, meaning that we are 90% confident that the population variance lies between 1.4076 and 31.25. Let's try the last example. So a statistician chooses 27 randomly selected dates, and when examining the occupancy records of a particular motel for those dates, finds a standard deviation of 5.86 rooms rented. Okay, so meaning that this 27 refers to number of sample taken. Okay, and this out of this 27, it finds that the standard deviation of 5.86. So it will be your sample of standard deviation is 5.86 rooms. So if the number of rooms rented is normally distributed, find the 95% confidence interval for the population standard deviation, okay, of the number of room rented. So here we have our N and our S. So using the formula that we have, we know that the confidence interval for the population of variance. Okay, so first we just have to find the population of variance, S square over chi square alpha over 2 n minus 1, okay, sigma square n minus 1, the sample of variance, okay, chi square 1 minus alpha over 2n minus 1. Okay, but okay, here this is the formula for the population of variance, but here for our problem we want to find the population of standard deviation. So what we can do is just, instead of finding this sigma square, okay, we know that to find the standard deviation we just have to find the square root of the variance. Okay, so now we have the n and we have the sample standard deviation. Okay, next is we need to know the chi-square value. Okay, here given that this is our confidence interval, 95% refers to 1 minus alpha, which is 0.95. Okay, so alpha would be equal to 0.05. Okay, and then for alpha over 2 it will be equals to 0.025. So meaning that we have to find the chi-square alpha over 2n minus 1. So here would be equals to 0.025. So your n is 27. So 27 minus 1 is 26. Then the second chi-square you need to find is 1 minus alpha over 2 and minus 1. So it will be chi-square 1 minus 0.025, which is 0.07526. Okay, and you will get your chi-square here is 41.923, and this one would be 0.975. Okay, and here would be 13.844. Okay, so using the chi-square table. Alright, so now just substitute the value into this formula. So you have 27 minus 1, so your s square, so here is s square but this one is s, so just square this value, 5.86 square divided by chi-square alpha over 2, which is this one. Okay, less than the population standard deviation. And then here we have 27 minus 1, and this s square is 5.86 square divided by 13.844. Okay, now we solve this, and you can see that the confidence interval, okay, 95% confidence interval for the population standard deviation falls between 4.62 and 8.03. So this is the end of this video. So please try this exercise and compare your answer with this provided answer here. Thank you.